Hello, this is an introduction to one of the what they call suddenly everyone is talking about type of a situation, and of course I am talking about rapid prototyping, and one form of rapid prototyping called 3D printing seems to has attracted everybody's attention, because what happened to in the case of publishing. In publishing, what do we do? Somebody writes, it could be a novel, it could be a theoretical paper, or it could be anything which involves to be printed and distributed everywhere. So, in the beginning we had this typewriter, somebody had to sit and keep on doing the typewriter. So, we have the Underwood and the Remington and Brother and so on and so on. And then all writers invariably went and acquired one of those new typewriters, including there were small portable foldable and so on. And the old business of writing by hand, taking a pen and writing by hand sort of became a little, it went into the background, but still people continued to use writing, which is real. Now, after the typewriting was come, somebody had to now go and do what is called typesetting. So, if you want it in large numbers, a few things you can do by putting what is called a carbon paper, and hence the CC, carbon copy, came about. You see, all of them has a reality in original real products. So, carbon copy came about. After the carbon copy came about, if you wanted to print a large number of any material, we had to send it for typesetting and printing. So, somebody puts all those letters and then it's run in a press, and something, a paper is pressed against it and all that. So, that came about, and almost intellectual meant publisher, and publishers needed money. So, this whole thing became sort of expensive, and from that thing came the concept of desktop publishing, saying why do you need to have this huge calendar presses and photo offset, multicolor and all that, why can't we do it at home on a desktop computer. So, in the desktop computer, what people used to do is print everything and probably format it, change the fonts, and then make everything fit into a known format, hand it over to somebody who will print it and give it to us and get multiple copies. And it went forward a little. Eventually, when it went forward, it ended up with tabletop printers. So, it was easy. Allow me, just for the argument right now, use the word Xerox. In fact, Xerox Corporation, who incidentally probably has a patent on this mouse, okay, they started making printers, huge printers, and to the extent that what was a trade name eventually became a verb, get it Xeroxed. And now we know photocopying is almost synonymous with it, but the thing what I am trying to stress is that there is this printing has been made very easy. So, you have printers which will give you multiple copies, then there are institutional printers and so on. I have a small write up which I will try to come back later. So, people were working on it, saying if I need to make something, typically I need these glasses, and it is also made with some black material, you can see it, no? And imagine I have a tube of acrylic or a tube of something which will harden fast, like if you see the glue gun, you have seen the hot melt adhesive gun. So, in the hot melt adhesive gun, what do we have? We have a a thick what do you call some device which melts that thing, and we have a gun where in the tip it heats and makes it a little easy to flow, and people started tracing what do you call patterns and all that, and what was adhesive between two things also became something which you can play around with it. Almost you can make a type of glass. You have seen all those huge what do you call church glasses, stained glass type of things were possible, all based on the hot melt adhesive. Now, while this is one side, another side what is called the inkjet printing started getting popular, saying why do we have to have a photocopy type of thing, why can't we have an inkjet where ink is actually pushed into small slots and that thing afterwards it's cured and come about. As people started working on it, suddenly somebody, I do not know who it is right now, I am just not talking about it, they came about with what was obviously simple printing using some wire or something, you melt it and start printing things with it, and suddenly the whole what is now almost we feel it is going to solve all the world's problems, 3D printing. But 3D printing is a small set of rapid prototyping. What we want is that quickly, if I have some concept in my mind, I have some concept, I am not sure what the concept is, I have this is a base and then this is something, this is a tip, and then I need to do something with it, maybe I need to erase, and something which is there in my mind has to come down so that I can demonstrate it to others. This is where the whole concept of what was prototyping and then what was what do you call rapid prototyping, eventually an idea which a time has come, 3D printing came about. Now, if you kindly look at this thing, one of the thing is why we need this 3D printing stuff is we need this simulation. In industrial design, a product has to be experienced in its intended human environment, has to fulfill all its functions, not just technical, and alternatives have to be evaluated. So, you see here one of the first thing is how products look like, general look and feel, ergonomic. Ergonomic means how well it sits in the hand and then how well you can use it, and usability, direct sensory inputs, touch, balance, comfort, appearance, and occasionally smell and sound. So, it looks a very what you call counterintuitive, saying why do we need sound? We need, if any of you have handled a camera, you will notice that shutter relay sound is the, unless it gives that sound, we will not get a feedback of how things have operated. Now we have got used. When we started, we all started with that big clackety clack cameras which had mirrors, and we used to listen carefully whether the mirror has gone up, and then usually there is a focal plane shutter, the focal plane shutter has opened, and then the mirror has been restored to that. All this you can easily find out if any problem is there. And when these mobile phones came first time, we have nothing here, isn't it? We just have, I mean there is nothing to press. In fact, both the front and back of this are glass pieces, and when we press something, something has to happen, and while it looks fine, and sometimes you have a buzzer at the back, it vibrates, or we have something. Occasionally we end up with very peculiar things. I will try to show you. You see, I have a very peculiar Indic character keyboard here, which a little similar to what we start, but then when I press a key, you see a wheel like thing has come, and I can move things around, okay, and see which of these is selected. Suddenly what looked like a tactile feedback not needed anymore. And what do you do with, I do not know, it's called a chakra. What do you do with a chakra like this? This was developed instantly by Industrial Design Center of IIT Bombay, and I am a fan of this, that whole thing. Now you see here, what we thought was a generally a keyboard, simple keyboard, has several other ways we need to work with it. This is where, now if you come back to my slide, sound, all they suddenly make a, what do you call, a comeback. This is where 3D printing at least promised, saying very quickly I can make things and present it to the public, the stakeholders. In this case, one is safety, another is manufacturability. How easy it is to manufacture, how is the best ways to produce, and then tooling, and then assembly. What comes in first, what comes in last, and all of us are, when it comes to maintenance and assembly, our good old friend is waiting, Murphy, saying if you open one screw and something, and invariably that nut or screw goes and hides in the most inaccessible place. So, how do you disassemble parts, and then how do you update the system, and then how do you diagnose this? All these things are generally the best way to do is by manufacturing a prototype. So, we have all this, so and then we have rendering and thing and all that. I will stop here and quickly go back to the interesting thing which I am sure quite a few of us are waiting. This is the concept of 3D printing, which is a small subset of rapid prototyping. You see here I have a very interesting object, which is probably nothing but it is a peculiar heat sink. If you see here, for it to be manufactured, it has to be held in different places, and a cutter has to move in all the directions, and this has to be ready. And from various considerations, I would like to have one in my hand, because it is not easy to interpret these things. While it looks okay here, such things suddenly made sense to be made in 3D printing. So, in 3D printing, that is typically a machine. Let me go back to a few more parts. You see here, notice something about this clock. It is a 9 to 5 clock, and you see where the 1 o'clock is. This does not start at 12. Out here in colleges, we have a recess at 1 o'clock, noon time. So, the whole perception of the student is everything is before lunch and after lunch. So, 9 to 1 is all the sessions before lunch, and then after lunch is there, and suddenly you have noticed the other 6, 7 thing is not there at all. Now, this was just directly printed on a normal printer, an A3 printer, and it is stuck there. Imagine I need to now make this clock, and you see some very interesting things are also written there, saying work smart, not long and hard. Long and hard makes sense in some other thing, at least the semantics of it. Working smart makes sense. Now, you see other things are also, all the other elements, it is a 9 to 5 clock, and then there is no minutes hand into there is only an hour hand. Approximately if you look at it, it is just past 2. So, you can look at it, maybe it is 9:20 or anything. In this case further it is not divided into 5 parts, it is divided into 4 parts. So, it is a quarter past 2. So, suddenly what was, I can now print the whole thing. I feed, just like I have the black and white printer here, I can feed it to a machine here, and eventually I can have a beautiful 9 to 5 clock, and 9 to 5 are normal working hours, and 5 to 9 of course you evening times people get a little bit of relaxation, morning they start running around, and there is work all the time. Now, this whole device, including the colors, including the shape, including the fonts, everything can be designed in CAD and you can go ahead and print these things. So, I am amazed at it, as I just produced this as a student exercise. And you see here I have some other part, I do not even know what it is, except that you see a small detail, there is a groove here, there is something here, and then this was supposed to be something for a shape memory alloy motor. So, if we excite a wire, I mean electrically pass a current through the wire, it clamps and runs something. So, we have all these parts which can easily be produced using this 3D printing technology. Typically, this is what you would have seen this outside, and why I feel I am a little happy for getting this chance of being allowed to talk about this 3D printing is we have been at it for quite some time. This machine has been first I started using it around 10 years back, and since 6 or 7 years it with us. I will show you the samples what we have put. This is a professional machine. The advantages of a professional machine is it will take any drawing which you make, and the drawing formats are typically what standard products, standard what you call software gives. One of the standard software is probably related to Autodesk, who started with the DWG format, and even earlier to that the initial graphic exchange IGES system was also there. And the advantage is if I make a CAD model, it can be printed here, and same file in principle can be used for carrying out other operations. Simplest thing being machining using a 3D what you call machining center. It is either a CNC vertical or horizontal thing. Now, slowly things have changed a little. Okay, let me get back to this simple thing, and better to do it. In principle, there is nothing great about this machine, but why this is costly I will give you an example later. There is a shelf here, we load the base here, and then there is a screw feed here. The screw feed keeps pushing it up in layers. This is where standard lithography files became popular, and this one at the back is an XY system. So, the Y is front to back, X is left to right, and this is the Z or Z coordinate. Now, things have improved dramatically. You have seen here, this is the same machine 10 years later, the latest technology, it has become much smaller, and genuinely it is easy to fabricate these things. And you see these are all the parts that can easily be produced in a 3D printing setup. There is something, there is actually part of a Fresnel lens. I will use the word Fresnel, put up with me, because even calling it Fresnel is probably not how the French call it. They call it probably Fresnel or something, I do not know what it is. This is part of a Fresnel lens complex, and the next slide shows you, you see here, we want it, you understand. We want this piece, it has a peculiar what do you call part of a sector radius, there is a opening here, and then this whole thing has to sit here and it has to come out of the machine. Now you see here, what I am holding in my left hand is the piece, right hand is what not many people tell you is the support material. In the case of that professional machine, there is a poly, I think some acetate, allyl acetate or lactic acetate material which dissolves in water at a temperature which is lower than the basic other material. So, this build material, after having built it, we put it in that socket, and there is a small agitator and there is a ultrasound, and the whole thing comes apart, and then we take it out and we can use this part conveniently. So, if we keep going, this is one or two things. Notice there is a little coarse build up here, is a little coarse, and you see here same thing, the build up is a little fine. So, inside, and you see something else here, this is the base on which it is printed. And this is where actually 3D printing became very, very popular. Not long ago means around 15 years back, if somebody were to make a part like this and try to show it to an injection molder, it used to take ages to get this. First of all, somebody has to convert what he has in his mind to a standard 3-view drawing. So, you have a various views saying what you call, you have a plan view, you have a elevation and side view, several section views, plus something which not many people like is an isometric view. Suddenly you need not worry about it. If you know a little about how to use any package, you can make this on the screen and print it immediately. A little romantic, but it is real. But you see here same thing, how well all the small details, like you have small bosses, then we have something here, little detail, everything can easily be made here. This is one of those interesting thing. A schoolboy wanted to make a ornithopter, but not using the standard what you call Da Vinci's mechanism, saying why can't you use it using gears and using other things. So, when he asked one of us, we said, okay, you tell us what you want and we will print it. There is a perfect to form, means good to the rule, involute gear. This section is a rack section, this whole thing is a rack section. What you see here is a pure rack, means they are tapered like this, and then slowly as you go here, you see here, now you see full involute tooth profile. This was only possible using generating the form by CAD and then later on printing it using the fused filament method. So, in a way I am happy and I do not know what has happened of him. And in the initial stages this became very, very popular. I am sure this symbol, all of you will know this symbol, and I will acknowledge this. So, we have the original MakerBot. MakerBot probably brought this to our genuinely to our attention. But if you want to make a replica of something, first of all you need to do something. You see the replica, this is the device which is the scanner. So, you keep something, probably I think this is the target which they have given, is a MakerBot target they have given for the linearity and all that. It rotates and any object you can keep on it can be converted into a 3D file. Format I will not say right now, printing format is STL, otherwise it is a file. So, suddenly we are in beautiful company, and the crux of the whole thing is what I had told you earlier. It is a lot like a hot melt glue gun. So, you have the build material flowing here and then you have a nozzle at the bottom, and this nozzle sort of moves everything around. I will come back to it later about the actual that mechanism, but if you see here, whole crux of the whole thing is an XY table. That is all there is to it. Anybody can, if you can make an XY table, you can make your own 3D printer. So, this is taken from one of our students work, and you see there is a head here. This is used for various things. In this case, they have just used it as a calligraphy pen. If you can have a font, that pen writes it for you. And it is not as if anybody invented it. XY table is an old thing. This is taken from a a type of a Gerber plotter which has been used for making printed circuit negatives. So, it has been there. So, I mean to make it short, I will show you. Even this is even simpler. It is a kit. You have two motors, it moves up and down. If you can have a vertical thing in layers, you can do it. And this is not a toy, it is a serious learning experience. This one is a line follower. So, in a line follower you know what it is, no, you usually have 3 motors. The option there and the other thing is whether you have a steering wheel or you have a caster. In this case it is a caster. This whole thing, if you see the base of it, no, could have easily been made in plastic. Probably it is, probably it is an acrylic in which all these openings have been made. Except that in operations like this they use laser milling or laser cutting to make these jobs. So, I will just go a little forward, and things went on quite well, and I think some of you know where it is, no. Okay, this has come from the one of the original hard disks, or I am sorry, floppy disks made out of non-ferrous casting. Probably it is a zinc aluminum casting, and you see the detailing and all. So, attempts have been made saying why can't we print all these things directly in things. And as things have progressed slowly, the issue of design rules came about, saying in the case of, you see here at the extreme left position, no, we have all this fused deposition, stereolithography, laser sintering, material jetting, binder jetting and all that, no. It is saying how much should be the feature detail, supporting walls, unsupported walls, overhangs and all this, no. Several, these are actually not rules as such as much as guidelines. Depending on your interest, you can play around with it. And initial stages people did not know too much about these things. Can you see here now? If you see that filament, what do you call, just fuse and deposit does not really build up as we think, as we are. You have seen here we have all this stuff. What is layer shape, what is the slice diameter, actual diameter, there is still a lot to be learnt about it. I just showed it to you from a random thing. So, I thought I will just show you all these things. Okay. Now, if you go to the, I loosely call it the internet. If you search on the internet, you get multiple hits. I just wanted to show you. You see here, I just loosely gave, I did not say Alexa give me or Siri tell me or anything, I just said, no, typed actually. So, a little about 3D printing. You get lakhs of hits now. Study on 3D printing, how 3D printing works, and so on and so on, no. Printing technology, introduction to 3D printing and all that. All that is fine for reading, but unless you make actually a part and then try to build it. You have seen this, we have a beautiful thing about how to design parts for FDM, fused deposit modeling, by what you call default. This has become so lot of stuff about what is an introduction and then what is a bridge and then how do we build these things. These come only by practice, practice and practice and practice. So, how to do vertical axis, this is taken from these things, no. And then what to do with overhangs, you see here something which is started here is coming up so much. As you start making, you see here it can't build anymore here, it is reasonable here. The granular tissue starts after about maybe 10 degrees maximum, and then by the time it reaches 60 degrees it is practically non-usable at all. So, things like this saying, and then what to do with all these things, no. What is called simple filleting. So, it has got a new name. For adjacent corners, first layers are particularly important. As discussed above, for vertical holes, so on and so on, no? It compresses the print material. So, what is called elephant's foot has to be created. So, we have this stuff about how to build things. So, it is not automatic, as if you somehow make a beautiful 3D model and things print on itself. This is the most critical thing you can think of. If you are to take a circular part and try to print it like a cylinder, similar to what I showed you, that shape memory alloy thing, it weighs lot of support material and often it leads to errors. Same thing, is it possible for us to do something about it, saying if you build it like this, probably no support is needed. Like when we build an arch, as you start building an arch, things get easily built in it. Yeah, this I have already shown you. So, things are have been very conveniently made, and we come into more and more what do you say, interesting things, saying directly material is available on the this design guidelines, saying how do you do like plastic design. Oh sorry, a lot depends on 3D printer resolution. What we assumed is automatic is not automatic, and it varies within parts. These things I thought this what do you call I will try to stress a little and then try to things like spacing and clearances, interlocking volumes, piece assembly, and something related to tolerances, and how to deal with flexible plastics. These suddenly have become very popular. Only thing what you see in what you call the commercial literature is saying, if you think it, we can make it. And I wish things were so easy. It is not so easy. If you can think, we can't make it. They are not at all that easy. So, I can only say welcome to the course, and who will be benefited? Somebody who is keen on learning a little about it, and the good news is that there are printing services are available. Just like earlier you could take, and even today no, you do not need to own a printer, because printer is given away cheap, but the cartridges are expensive. Over here in India, right away we have tabletop what do you call the inkjets and all for maybe 5,000, but the cartridge color set costs 1,000 rupees and it just dries up. It has an inbuilt time bomb and kill switch. Automatically it goes but if you do not use it, or if you open the seal, it looks like 3 to 6 months everything shows empty. Hence you need not own a printer. Same way, lot of open source solid modular or 3D packages are available. So, if you somehow learn how to use one of those packages, it is very convenient for you. If you can make a solid model and pass it on to one of the printers, you do not even need to see the printer, just give it to him, and beautifully I have a keychain. So, I was thinking the other ways, saying why can't I do something, why can't I hide it, why can't I have a LED light and all this. If you can think of a part like this, it is very easy to be made. When I pull it can be like this. When I do something and slide it, the whole thing can probably be hidden inside. Right now I kept it at the back. Can I make a part like this, or can I make it like a pouch, side is open, I slide it in and then it goes inside. All this, if you can think of a design and probably follow all these various considerations, you can post it, you can send it on of course not on social media, but you can send it by a regular paid email and you can have the part mailed back to you. So, as a trial thing, I feel it is a worthwhile thing. I think all of us now should probably try it and will be better off for that.